Bismillahirrahmanirrahim. Dear students, yesterday we completed lecture number 17 and I gave examples of galvanic cell, especially for the Daniel cell. There is one example in your book. Already I advised you in the previous lectures, please, when the teacher is going to be teaching, you should have your own book. You have to see the book very well. So dear students, if you see the page number 171, there is a self-assessment. This self-assessment is 7.6 self-assessment. There is one very good example is given here. This will be help you in the next classes. This again example for the galvanic cell. And the question he asked, identify the half cell. Identify the half cell in which oxidation occurs and half cell in which reduction occurs in the following diagram, and also mention the flow of electrons, from where the electrons flow, and also write down the half cell reactions for this by using this diagram. So this is example of galvanic cell. So I will explain the proper name for this one. So there is a proper name for this chemical reaction. Dear students, there is one thing important. If you see my previous lecture, Daniel cell especially, so we use two electrodes, zinc and copper. And I told you in the lecture number 17 yesterday that you have a copper and zinc and redox reaction taking place. The voltmeter show 1.1 volt. If you remember, you can revisit this lecture again. 1.1 volt is measured by this Daniel cell. Now the question is that from this cell, if we don't know 1.1, we don't know. If there is another cell, suppose unknown cell we have, and the examiner asks you, please calculate the inward cell electropotential cell for the one half cell. Suppose he say for the zinc, calculate zinc if you don't know the overall. Suppose he say calculate for the copper. So you are unable. You will be unable to calculate the E naught cell for the half cell reaction. Suppose you know this is 1.1, if you know, okay. So what will be the for zinc? What will be the copper? Both are different. You can't half this. You can't divide by 2. No. According to electrochemical series, every element is going to be reduced to give a different kinds of electropotential reduction according to electrochemical series. So you are unable to determine the electrode potential for the half cell reaction by using Daniel cell. Daniel cell is used to calculate the overall redox electrode potential 1.1 volt. So dear students, this self-assessment 7.6 will help you. If you understand very well, this will be help you to determine the electrode potential for the half cell. Also mention its name. It has a special name. I'm going to write its name. Also you have to write name in your book also. You will forget. The name of this cell is standard hydrogen electrode. The name of this cell, which is galvanic cell again, voltaic cell again, especially the name is standard hydrogen electrode. So by using standard hydrogen electrodes, you will be able to calculate the E naught cell for any off cell reaction. There the reason. Standard means known. Standard, we know it. Standard condition. So when I am going to construct this, construction of this cell, standard construction of standard hydrogen electrode first. This is the container. This container contains 1 molar solution of hydrochloric acid. 1 molar solution of hydrochloric acid there is. And there is a this is called a glass sleeve made up of glass. This is called a glass sleeve made up of glass. And here is a platinum foil. Platinum foil made up of platinum metal. This platinum foil is connected with the platinum wire. I told you platinum is a very good electrode. We use as an electrode. So this is the platinum wire which is connected with the platinum foil dipped in 1 molar solution of hydrochloric acid. This is a 1 molar solution of hydrochloric acid. There is. So this is the platinum wire and this is a glass sleeve made up of glass. The whole outside, this is a glass. Whole. This whole glass is a glass sleeve. Now from here, the hydrogen is going to be passed through. Hydrogen gas is passed from here inside. Hydrogen gas. And this end of the cell is connected with voltmeter. So this is the platinum wire which is going to be connected with voltmeter. This is a voltmeter. So there, this is needle is like 0. There is 0. There is 1, 2, 3. I will then working. I will explain this. This is a voltmeter connected here. On other side, you can use any half cell. And yesterday I told you when I use zinc, so you have to prepare 1 molar solution of zinc sulfate and put zinc rod. If you are going to use copper, then put the copper sulfate 1 molar solution and dip copper rod as electrode. If you are going to put silver, then put the silver nitrate 1 molar solution and put the silver as electrode. So then you will be able to calculate the half cell electrode potential for the copper, for the zinc, for the silver, for the iron, and I am going to explain how. So this side suppose according to your book, this is going to be 1 molar solution of zinc sulfate. 1 molar solution of zinc sulfate you have to add here in this one. Here. And dear students, here is a zinc electrode. zinc electrode made up of zinc metal. This is a zinc electrode made up of zinc metal. And now this side is going to be connected with the another part, another terminal of the voltmeter, to connect these two with the voltmeter. Now yesterday one thing I explained to you, that was a salt bridge, the function of salt bridge to connect the solution together, not mix. It prevents mixing. The solution will not going to mix with each other, going to be connect with each other. So I use a salt bridge. This is a salt bridge. The end is closed for prevention of mixing. Salt bridge. This is a salt bridge. Now this salt bridge, yesterday I told you, potassium and chloride. Okay. Potassium chloride is going to be used in the salt bridge. So this chloride, now there is one big question. Which will be used as an anode and which is going to be used as a cathode? Where will be an oxidation and where will be a reduction? Either this zinc and zinc sulfate electrode acts as an anode, or this standard hydrogen electrode. This is a standard hole. This whole apparatus is standard hydrogen electrode. I will explain why we call it standard hydrogen electrode. So again I am explaining you the construction of standard hydrogen electrode. There is a container, beaker, electrolytic cell we call. So this contains 1 molar solution of hydrochloric acid. 1 molar solution of hydrochloric acid we add here, and this is a glass sleeve made up of glass outside this one. And this is a platinum wire. This is a platinum wire is coming here, and this connected with a platinum foil. And hydrogen gas is going to be passed through from here. So it creates bubble. When it is going to work, I will write after when it will work. And this side, there is a 1 molar solution of zinc sulfate. I told you can put any means of copper sulfate. You can put copper. You can use for iron. You can use for manganese. You can use for also silver modern maybe. So I put here zinc here. So zinc is an electrode and zinc sulfate is electrolyte. We pass electric current from here, and there these two ends are connected with the voltmeter. Now this is complete. The current flows. This voltmeter will show the electrode potential, but how much? And which one is the electrode oxidation and which one will give reduction? I told you yesterday, and also many times I repeated, there is an electrochemical series. Electrochemical series in majority of the books, if you visit grade 11 and other on internet also, electrochemical series written reduction potential, standard reduction potential for the ions, standard reduction potential. So you will find a table. Reduction potential, if you find top, they are in minus, negative sign, means they are going to be oxidized more. And hydrogen you will find middle. Hydrogen has a 0, I am telling you. The electrode potential for the hydrogen is 0. Either it is going to be oxidized or reduced in middle. It is a standard. Above the hydrogen, their reduction potential, all they have a negative. Below the hydrogen, standard potential for the all ions are going to be plus. hydrogen is for the 0. So standard potential for the zinc, which is in the top, it has a minus 0.76. The cells which have a reduction potential negative, they are going to be oxidized. They act as a anode. So hydrogen is 0, greater than minus 0.76. So students, just is a revision for you. This is what in your syllabus. Only I am explaining that which one is the anode and which one is the cathode. So here, zinc and zinc sulfate acts as an anode. This is the anode. Zinc acts as an anode. Standard hydrogen electrode acts as a cathode. So at anode oxidation and at cathode reduction taking place. So there, if you are going to now working here, you will find bubbles. Bubbles of hydrogen from here. Bubbles of hydrogen will be formed here. There in this cell 1 molar solution of hydrochloric acid. Now, when you are going to work it by voltmeter, so I am going to write first anode reaction. At anode always oxidation, there is oxidation, anode oxidation. Yes, there is oxidation. So zinc 0 changes into zinc positive 2 by the loss of 2 electrons. Now, dear students, it means that zinc metal is going to be dissolved to form more zinc ions. More zinc ions are going to be formed in the solution, and zinc is slowly and gradually going to be consumed. So this is the anode reaction. This is called oxidation. Maybe in the new edition of this book, correction is going to be made, but in the old, one equation is wrong written in the book. So cathode. In cathode reaction, because zinc is going to be oxidized, so standard hydrogen electrode will be reduced, decrease in oxidation number. It means that the hydrogen ions in aqueous solution, they are going to be form hydrogen gas. Bubbles of hydrogen gas come out. So hydrogen gas is going to be formed. So these hydrogen ions gain 2 electrons to make a hydrogen gas, because the oxidation number decreases. There should be one oxidation and there should be a reduction. So hydrogen ions changes into hydrogen gas, and I told you standard hydrogen electrode oxidizes or reduces. If it is oxidized, its electrode potential will be 0. If it is reduced, also 0. So that is why standard hydrogen electrode will give E naught cell 0.00 volts. Now it's clear. Students, now it's clear. If I know the standard electrode potential for the hydrogen means this one, so this voltmeter will be shown only for this. The voltmeter will show the standard electrode potential for the oxidation of cell for zinc or any other. So I can calculate for this one half cell. So in the electrochemical series, when you visit the electrochemical series, there in the table, all the values are calculated by using standard hydrogen electrode because it is arbitrary 0. It is standard, its value is 0. So if its value is 0, then you will be able to calculate the electrode potential for the zinc. And yesterday I told you this will give a 0.76 volts. Yes. So for the E naught cell for this standard halogen electrode will be a 0.76 volts because the hydrogen electrode is 0. So I am writing here hydrogen ions in aqueous solution and the hydrogen gas 0. E naught cell will be 0. E naught cell will be 0. It means that if the standard hydrogen electrode is going to be reduced, also 0. If the standard hydrogen electrode is going to be oxidized, it is also 0. Now the conclusion is that what's the benefit for the standard hydrogen electrode? If I told you like this one, here is a hydrogen, here is a hydrogen, so it gives a 0 value here. So above they are all negative and these are the positive and this is 0. So above the hydrogen they are negative, they are going to be oxidized. It means that above the hydrogen, whatever the ions present, they are going to be oxidized and standard hydrogen will give the 0 reduction and then you will get the value for this one. Now if you are going to be used for down here copper, if I put copper here, copper is down the hydrogen in the electrochemical series. Plus 0.34 voltage reduction potential for the copper. So if I put here copper sulfate and copper here, so this standard hydrogen electron will be oxidized and copper will be reduced. Again you will calculate the voltage for this one. So dear students, this is also an example of galvanic cell, and according to the questions, write the half cell reactions I have written, draw the diagram and mention the direction of electric current. So it should be from anode to cathode. It should be from anode to cathode. Flow of electrons, direction of electrons always from anode to cathode. So there is oxidation at anode and there is a reduction at cathode. So please, you have to revise very well for this one. And this is a very important cell for this one. There is one more example for this. One more example. So this is a very complicated. You will learn in the grade 11 in detail. So I will give you, and inshallah your concept will be clear when you are going to concentrate with this one. And my advice is that you have to note in the copies and see your book, self-assessment 7.6 written here, and name is not written. So write this is a standard halogen electrode. And I give you a detail about this one whole. And I told you that standard electrode either oxidized or reduced, it gives a 0. And no need to give a current, electric current. This is a spontaneous reaction. This is a galvanic cell. Spontaneous reaction taking place. So there is one more example in next topic I will explain. So dear students, you have to concentrate this very well and make questions. Thank you very much. I will start next lecture now.